Good evening and welcome to the Queen's Lecture 2020. I'm delighted that you joined us this evening for this virtual version of our annual event. My name is Miriam Lawrence. I'm the Regional Director for Science and Innovation from the Foreign and Commonwealth and Development Office of the UK. And I'm delighted that this evening we're joined by Dr Emily Shuckburgh, who is from the Cambridge University, and I'm also glad to be joined today by Professor Christian Thompson, President of TU Berlin, by Paul Smith, Director of the British Council in Germany, and by Robbie Bullock, who is the Chargé d'Affaires in the British Embassy. Before we start, I wanted to remind you that you can start submitting your questions as the lecture is going on. You can do that either via the live stream chat or on Twitter using the hashtag QL2020. But to start things off, I'm delighted that we have a video message from Berlin State Secretary, Mr. Stefan Krach.
Dear Professor Shuckburgh, dear Robbie Bullock and Paul Smith, dear Professor Thompson, dear students, ladies and gentlemen. It is my great pleasure to send you our best regards from the Berlin City Hall, also on behalf of our governing mayor, Michael Müller. The Queen's Lecture at Technische Universität Berlin has a long tradition and is a highlight of the Berlin Science Week, which features over 200 digital events this year. These are very special times for us all. The current COVID crisis underlines the importance of research and innovation for our societies. It also shows us again how important it is that we work together across borders to find solutions to the pressing questions of our time. Berlin is proud to be the most dynamic center for higher education and research in Germany, and we want to become one of the world's leading innovation hubs. But we know it is the idea of cooperation that makes us strong. Cooperation between the institutions within our city and cooperation with partners around the world. The Queen's Lecture stands for the strong tradition of cooperation between Berlin and the United Kingdom. And I can assure you that we are strongly committed to continue this long and fruitful tradition in the future. Climate change is one of the pressing topics that need global answers, and our universities are taking the lead to build new, bold climate change initiatives. The Cambridge Zero Initiative and the Climate Change Center Berlin-Brandenburg, championed by Technische Universität, are two great examples of such efforts. I would like to thank Professor Shuckburgh for holding this year's Queen's Lecture and Technische Universität for sharing it again via the live stream with the general public. I wish us all an inspiring lecture and would be delighted to welcome you to Berlin in the future.
Well, thank you very much, Secretary of State Krach, for your kind words at the beginning of our lecture. My name is Christian Thompson. I'm president of TU Berlin, and it's also my pleasure to welcome all of you here. Just to get to know you a little bit, Emily, would you be able to tell us what made you think about climate change? What made you work? What made you put your entire scientific emphasis in this field?
Oh, that's a very good question. So I started off as a mathematician. That's what I studied as an undergraduate. And I really wanted to use that mathematical understanding to better understand the world around us. So when I started on my research career in the early 1990s, I decided to focus on understanding how our climate worked. And that was at a time when climate change itself was only just starting to come on the political agenda. And I've been basically conducting my research career at a time when the world has become increasingly aware of the threat posed by climate change. And so most of my scientific studies have been looking at climate change, particularly in the polar regions, understanding how both the Arctic and the Antarctic are changing and how the changes that are occurring there affect all of us around the world. And in the last couple of years, I have started to focus not so much looking at understanding the problem as focusing on understanding the solution and how we can bring science and technology to bear to try and help shape the solutions to climate change.
Very interesting, Emily. Maybe I'll pass on to Robbie Bullock from the British Embassy.
Yeah, sure. Thank you very much. And I had a similar question actually, but I might change it a bit because I was going to ask if you could explain a bit your scientific background, but you've just told us that you started out with maths. So I wonder if you could tell us a bit about how you apply that maths to the work that you do now.
Yes, actually. So all the way through my career, I've used mathematics in very many different ways. So mathematics itself is at the absolute centre of all our computer modelling of future climate change. And so it's critical to be able to use the mathematics in that sense to help make predictions of the future. But there's also many other ways in which mathematics applies. Most recently, I've been looking at how we can apply the latest advances in machine learning and artificial intelligence to better understand the various amounts of data that we have, increasingly understanding different aspects of how the world is changing. Data that's coming from satellites in space or data that's coming from numerous sensors on the ground.
Excellent, thank you. And Paul, I thought you had a question too.
I do indeed. Thank you, and thank you, Emily. You're a member of Darwin College, a college named for clearly one of the world's greatest scientists in history, Charles Darwin. And at Cambridge University, you're at a university which has produced many of the world's greatest scientists, from Isaac Newton himself through to James Chadwick, from Ernest Rutherford to Stephen Hawking. How important is it for you and your work and your institute that you are in such a great scientific legacy at Cambridge?
So I'm leading an activity called Cambridge Zero, and we launched Cambridge Zero as a university almost exactly this time last year. And the intention was to bring all the university's resources together to help tackle the climate challenge. And that means drawing on all that scientific expertise that you just described, but not just the scientific expertise, extending beyond that, bringing in the lawyers and the economists and the social scientists collectively to try to help form those solutions that are going to help us navigate through the coming decades. And so it really, I think that it's not the universities in general around the world, it's the ideas and the innovations that are developed in universities that are going to be so critical to us in shaping, well, actually, a greener future.
Thank you.
Well, thank you very much, Emily, for getting us to know you a little bit. And I'd like to express my sincere gratitude that you are here, that you accepted our invitation for the Queen's Lecture at TU Berlin. Despite the circumstances, COVID-19 is influencing all of us. Doesn't make things easier. It actually has I don't know whether you can elaborate on that, a mixture and interference with the climate change, because in some ways people are traveling less, so there's less carbon dioxide emission. But is it durable? Is just everybody waiting until there's a vaccine and then they'll fly again as before? Or will there be a change that is lasting? We don't know. And I'd be curious about your insight on that. But let us get started without much further ado. It's our honor that we have you speak to us today. Ladies and gentlemen, the talk is entitled A Blueprint for a Green Future. Dr. Emily Shuckburgh, please, the floor is yours.
Well, thank you very much. So, as was said, I'm going to be talking today about a blueprint for a green future. And this is really the collective work of that multidisciplinary group of academics that I just described that have been brought together in the University of Cambridge under Cambridge Zero. That have been brought together under the banner of Cambridge Zero. Now, of course, we are living today in the midst of a global pandemic, and that has taken a toll, a terrible toll on lives and livelihoods and on the global economy. And the challenge now is in the coming months and years as we look to see how, as a global society, we can emerge from the coronavirus pandemic, how we can do so in a way that builds a better future. A future that is more sustainable, more resilient, and more inclusive for everyone. And so what I want to do today is offer a vision as to how we can go about achieving that. But let me just start with an assessment of where we sit in the world today, because as we look to recover from the coronavirus pandemic, we must face head on the threats that are also posed by growing social inequality, both regional and intergenerational disparities that are occurring in many countries around the world. Indeed, it's estimated that the world's richest 1% have more than twice as much wealth as 6.9 billion people. That's almost the entire global population. It's quite incredible. We're also facing a threat of to the natural world, a threat of extinction. There are estimated to be around 1 million species at risk of extinction over the next decades. And of course, there's also the threat that we're experiencing from climate change. Climate change is already being felt here and now today in terms of extreme weather around the world. And so if we're to look to build a more resilient, more sustainable future, we must do so in the context of those global threats. Now, this image here is from the University of Cambridge Primary School. And what you can see is the children from the primary school who were undertaking an art project earlier this year before the pandemic struck us all. And what they were doing, you can see them carrying boxes, and those boxes have different pictures that they painted on different faces of those boxes. And those boxes were intended to show different potential futures. The project was called Agents of Change, and the idea was that those children themselves could be agents of change. Those children can help shape a different future by turning the future to the image that they would most like to see. So taking inspiration from that, how can we all help to contribute to a better future? How can we help contribute to a fairer and more just society? How can we help contribute to a world where we restore nature such that the services that nature provide are kept in a resilient state for all of us, that we're able to benefit from the services of flood defences that nature provides and the pollination services it provides to all our crops? And also, how can we look to address climate change? Now, in terms of our recovery from the current pandemic, we can shape that in a way that means that we have a fairer distribution of our natural resources, that we shape a recovery that is sustainable, and sustainable because we have addressed the other underlying threats that are posed to society. And the great thing about this is that economic studies have shown that green recovery stimulus mechanisms in the past have delivered very strong financial returns. It is a good investment to invest in green measures. Now, before I go into details about how science and technology can help us in that green recovery, I wanted to pause just a moment. My particular research area is on the climate science, so I wanted to pause for a moment just to re-emphasise the scale of the climate challenge. This image here shows how global temperatures have been varying over the last 150 years as a colour scale. And you can see that as we move towards the present day, there's been this rapid increase in temperature. We're now about 1 degree Celsius warmer than we were 150 years ago. And 1 degree Celsius itself sounds like quite a small number, but as I've already described, it translates into a very significant risk of many severe weather events that we are seeing around the world today. Examples of flooding in many countries of the world, including repeatedly in the UK in recent years. Examples of wildfires that we're seeing in Australia and California in the last few months. And examples of heat waves. In some instances, heat waves that before any climate change one might have expected to occur just once or twice a century, now happening every few years. We're seeing in the polar regions that Greenland and Antarctica are losing ice at an accelerating rate, and that is contributing to sea level rise, which is also accelerating. we're seeing, along with those increasing temperatures, we're also seeing other impacts of increasing greenhouse gases in the atmosphere. And one of those is that carbon dioxide is increasingly absorbed into the ocean, and that is making our oceans more acidic, causing significant damage, for example, to coral reefs. So there are many different examples of where we're seeing significant damage to our world today as a consequence of climate change. And as the world continues to warm, the risks to people, to nature, and indeed to business will multiply. It's not just the damage to people's lives and livelihoods that we've seen from extreme weather events. It's also the way in which that impacts the natural world. The destruction of habitats of species that, as I've described, are already under threat of extinction is exacerbated the greater the temperature increases. And there are many different aspects where we've already seen damage to our economies as a consequence of climate-related changes. But perhaps the most concerning aspect of climate change is the risks of truly catastrophic shocks. And here are just a few of the examples that we are concerned about as the temperature continues to rise. The first is the potential for the rapid dieback of the Amazon rainforest. The Amazon rainforest soaks up huge amounts of carbon dioxide into the trees of the rainforest. But if that rainforest dies back and turns instead into savanna, then it will no longer serve that critical role. Carbon dioxide will increase further in the atmosphere, and we'd start to see an acceleration of climate change. To the other images you see on this slide here, often the polar regions. On the top right, you see an image from the West Antarctic ice sheet, and on the bottom left, you see an image from the Greenland ice sheet. These are vast ice sheets that are under threat from climate change. The Greenland ice sheet has seen significant melting in recent years, and the West Antarctic ice sheet is seeing melting from below as the warmer ocean waters around Antarctica creep underneath the ice and melt it from underneath. There's a real concern that as temperatures increase, that these ice sheets may not stay intact. And that could lead to many meters of sea level rise, which would completely transform global coastlines and displace hundreds and hundreds of millions of people. And the final image that's shown on this slide, the circle that you can see is a bubble of methane that's coming up out of an Arctic lake. There are vast stores of frozen methane in the Arctic. Methane is a much more powerful greenhouse gas than carbon dioxide, and the concern is that as the Arctic warms up, that methane may find its way out into the atmosphere, again causing an acceleration of climate change. Now, I wanted just to show you this image. So I've talked about the impacts and the potential future impacts of climate change. But why is that climate change occurring in the first place? Well, climate change is occurring predominantly as a consequence of our emissions of carbon dioxide and other greenhouse gases. And this data here, which comes from Antarctic ice cores, shows you just the scale of the change that we have caused to our atmosphere as a consequence of burning fossil fuels, cutting down forests and industrial activities over the past 150 years or so. What you can see here is there's a photograph there of a slice through an ice core that's been drilled into the Antarctic ice. The little tiny dots you can see are bubbles of ancient air. We're able to recover that ancient air and measure the carbon dioxide in it. And that's the data that you see in the graph here. It's data going back almost 1 million years. And you can see that the levels of carbon dioxide varied up and down in the past, between about 180 and 280 parts per million. But today they are dramatically higher, edging up towards 415 parts per million, as we have put more and more carbon dioxide into the atmosphere. And that means that today's atmosphere is absolutely unprecedented throughout all of human history, prehistory, and beyond. Now, if we are to limit future climate change, we need to cut our emissions of carbon dioxide and other greenhouse gases to zero. This image here shows global emissions of carbon dioxide over the last couple of decades, since 1980, steadily increasing year on year. And then the blue curve shows the direction of travel that our emissions must go in if we are to limit temperature rise to 1.5 degrees Celsius, half a degree more than we've already seen. And you can see we need to essentially reverse the increase that we've seen over the last 4 decades, over the next 1 or 2, to reach net zero by the middle of the century, by around about 2050. And to give you an indication of the scale of the change that's required, you see their projection for what the emissions are likely to have been in 2020. As a result of the global lockdowns that we've seen across the world, it is likely that emissions levels will be slightly lower this year. But the scale of the decrease that's required over the next 2 decades is equivalent to the amount of change that we've seen this year happening every year, again and again and again. So there really is a significant challenge, and that's the challenge that I'm going to discuss how we can use, in particular, science and technology in order to respond to. So let me then come to our blueprint for a green future, how we can design a green recovery. And I'm going to talk about 6 different dimensions of what a green recovery package might constitute. I'm going to look at it through the lens of the economy and what measures might need to be taken to help deliver a green recovery through economic stimulus measures. I'm going to look at it through the lens of society and what things do we need to be doing as a society at a regional and local level to help deliver a green future. I'll talk about the technology and how research and development, innovation can be accelerated to support a greener lifestyle, and what infrastructure we need in order to support that. I'll discuss how nature itself can be used to enhance our solutions to climate change. And then finally, I'll talk a little bit about the international dimension to all of this. But let me start, first of all, with the economy. So we've identified, in particular, 4 key measures that are important to consider in terms of an economic response to the current pandemic that would help support a more resilient, more sustainable, more inclusive society, but in particular that would at the same time help tackle the climate crisis and the destruction of nature. So the first key message is that there are many different stimulus packages that are being put together at the moment in many countries of the world to help support different industries that are suffering greatly as a consequence of the current economic limitations. But if we're going to look to support a greener economy in the future and a transition to a greener economy, we really must ensure that there are appropriate measures that are attached to those bailout packages such that they support a transition to more environmentally sustainable practices. We need to also expedite the development and use of new economic measures that better capture our social and environmental impacts. So in particular, looking at how we can redefine prosperity such that it's not only focused on growth, but also incorporates those important aspects of natural capital and indeed social capital measured by our well-being. We need to implement requirements that foster behavioural change in business. We need to see how we can try to enact ways of incentivizing businesses to behave in more sustainable ways, to disclose their environmental risks, and to capture that information through supply chains so that we take advantage of the fact that we live in a globally internet-connected way, to use those supply chains to reach across global economies and try to ensure that global economies become more sustainable economies. And then finally, and this starts to speak towards the role of science and technology, we need to remove barriers to green innovation and adoption. We need to support businesses of all sizes into developing the technologies of the future and deploying those at scale throughout society. Now, this just gives a little bit more of an indication of the scale of the challenge that we need to be responding to. This focuses on the UK, but it's a very similar picture in other European countries. And what's shown here is since 2008, the change in emissions, greenhouse gas emissions, from different sectors of the economy. Now, what you can see is that there has been quite a significant decrease in the UK in our emissions from the energy sector. That's shown in red. In the other sectors, there's very little change. The reason for the decrease in the energy sector has been predominantly because in the UK we use very little coal any longer in our generation of electricity, and that combined with efficiencies in general has resulted in that decrease. But in transport, industry, buildings, agriculture, waste, very little change. And the challenge is that over the next 3 decades, we are committed to reducing all those emissions to net zero. So we need to look to see how we can create a transformation in our transport sector, in our industrial sector, in our building sector, agriculture, and waste. And that's where the real opportunities for scientific and technological advances lie. Here's another way of looking at that. This shows, first of all, what our emissions in the UK looked like in 1990. And then they show the same emissions in 2020. We've, over that period of time, approximately halved our emissions. But what we need to do over the next 30 years is reduce them to net zero. And that means transforming each of those different sectors. Now, let me describe a little bit where some of the opportunities to do that are, because it's a monumental task. In terms of how society can help respond in the context of that huge challenge, there are a number of recommendations that we have in terms of how we can put in place the infrastructures and the support that are necessary to help society respond. And here are 4 of them. The first is that, as I think you probably just saw from the image that I showed, where it really does require a transformation of all sectors of our economy, that if we're really going to manage to create a transformation on the timescale that the science indicates is required, then we're going to need to undertake a transformation that is very holistic, that acts across the whole of economies. And that really requires a much more joined up approach than we traditionally have to addressing problems. And so our recommendation has been that, at least in the UK, we ought to look to establish some sort of delivery board. We're very much inspired by the sort of collective action that was put in place to deliver the London 2012 Olympics. We feel that in the same way, we need to have some sort of unifying mechanism to help with that transformation of so many aspects of our society. And of course, that needs to come with funding, but not just funding at a national level. Many of the on-the-ground decisions and implementations are going to happen at a local level, and support's going to be needed in order to be able to deliver that. Now, we're sitting at a moment where economies have been devastated, but so many people are suffering in terms of their jobs. And this is where I mentioned at the start, there is evidence that green stimulus can have a really significant benefit. So many of the jobs of the future are going to be in green industries, either developing the technologies or the infrastructure to transition to a greener world. And if we can invest in those jobs today, those jobs are going to be the jobs of the future. And then finally, and this is again an important role of universities, we need to review and overhaul the entire lifelong learning portfolio. We need to ensure that our children are being trained with the skills that they're going to be needing to navigate through the coming decades, that we are providing people with the training that's going to be required for the research and development of the technologies of the future, and with the skills to implement those technologies across society. So these are just some of the things that we're doing in Cambridge to help respond to that. I've already mentioned the children at the primary school who we've been working with to engage them in thinking about how they can shape a better future. We're working with our own students, both to encourage them to take leadership positions themselves in this area and to educate them across all subjects in terms of the ways in which sustainability is relevant to their disciplines. And we're also working closely with policymakers and businesses and others to support them in that journey as well. So now let me come to technology. How can we use technology to help support a greener future? And again, I've got 4 key messages from our report that I wanted to highlight. So the first is that there are key technology areas where we know that there are opportunities to make significant advances, and focused research and development programs will assist us in doing that. And one of those key areas is around energy generation and storage technologies. There have already been huge advances in photovoltaics, for example, over recent decades. But there are still significant advances that can be made, for example, in terms of developing solar glass. Significant advances that can still be made in terms of storage technologies that are going to be essential as we move to an increasingly electrified world. There's a transformation that can be initiated in terms of the construction sector, not just in terms of the sorts of materials that are used in construction, in particular concrete and steel, which have been such a major component of construction over over recent centuries. They are both very high emitters of greenhouse gases in their production. So can we look to be developing new natural construction materials that can take their place? But it's not just about the materials, it's also about the regulation and practices. And that's one of the key messages throughout our report, is that everything needs to be looked at very much in a systems thinking perspective, a systems-wide approach to some of these challenges, so that we integrate together the technological advances with the systems in which they sit. We also need to be looking at our transport sector. You saw on a slide that I showed a moment ago how transport is a significant percentage of our emissions. We know that the future is for electric vehicles in terms of personal transport, but we also need to be looking at how we decarbonise our freight sector, how we decarbonise shipping and aviation. And there's a significant programme in Cambridge looking at the future of zero carbon flight, how we can produce the aeroplanes of the future that are decarbonised. And that's a really exciting research avenue. And then the final thing on this slide is looking at greenhouse gas removal technologies. We put so much greenhouse gas into the atmosphere that it's likely that we're going to need to find ways of actively removing those greenhouse gases from the atmosphere if we'd have a reasonable chance of limiting future climate change. And there are essentially 2 different ways that we could go about doing that. We could either develop technological engineering solutions to try to remove greenhouse gases from the atmosphere, or we could look to nature to see whether or not we can use natural solutions to remove those greenhouse gases. But in each instance, we need to look very carefully at the potential trade-offs, the potential unintended consequences associated with those technologies, to ensure that whilst we're trying to do good, we don't do harm at the same time. So here are just a few examples of the opportunities under each of those different sectors for science and technology to play a major role in the transformation that's required. I've already mentioned a few examples from the transport sector in terms of, for example, zero carbon aviation. In the energy sector, I mentioned the future role and still possible advances in terms of photovoltaics technology and battery storage. But there are also other exciting opportunities, and the image that's shown here is of some experiments being undertaken in Cambridge to look at how we could produce artificial photosynthesis to generate the fuels of the future. We need to look to see how we can reimagine industrial processes, the production of key products such as steel, but also some of our pharmaceutical sector, to see how we can develop those in greener ways. I mentioned how we can look to see how we can develop new natural construction materials instead of those heavy carbon embodied products such as cement and steel. We can also look to agriculture. And this is one area in which both crop science, but also smart precision agriculture could help to deliver solutions. And there are aspects of agriculture where AI is increasingly being used to see whether we can undertake our agricultural practices in more efficient and therefore more sustainable ways. And then finally, in terms of waste, there are many opportunities for creating a less wasteful economy that's based on more circular economy principles. In terms of the infrastructure that's going to be required to help support those technologies of the future, I think I've emphasised a few times the absolute central importance of looking at whole systems, of taking a whole life view of infrastructure and the built environment, and not just looking at the possibilities of developing new technologies, but looking carefully at the way in which those technologies sit within a system, not just at the, for example, in terms of buildings, not just in terms of how we build buildings in more in less carbon intensive ways, but also how we operate those buildings in less carbon intensive ways. It's critically important that we put in place the regulatory and policy frameworks in order to support that. And at least in the UK, one of the greatest challenges that we face in terms of reducing our emissions is looking to see how we can decarbonise heating and cooling of buildings. Well, we are notorious for having some of the worst efficient buildings that we're all living in terms of our homes. They lose heat through lack of insulation. And actually that limits our ability to use new technologies. It limits our abilities to change from our largely gas-fired heating systems to heat pumps, which, as I'll show you in a second, are considerably more efficient. Unless you improve the insulation of buildings, those don't become viable options. So again, this is looking very much at a systems perspective in terms of the solutions. And then, of course, we need to accelerate the decarbonisation of our transport systems. Let me just give you just a couple of examples of where we have started to be looking carefully at how we analyse the different options for those technological solutions, because in many of those examples that I just gave, although the technologies exist or can be conceived of into the future, it's not obvious which are the best technologies that we should be advancing. And so here's just one example, and this is a study that we've been undertaking in Cambridge to look at different potential solutions for that challenge of how we heat and cool our homes. And there are essentially two different potential technologies. One of them is to use heat pumps to heat our homes, and the other one is to use hydrogen. But if you look through at the efficiency losses at each stage, through starting from if you're making your hydrogen from methane through to the eventual heat that is distributed as a consequence of that, you find that there is 3 times more heat per kilowatt hour of gas that's produced down the heat pump route than is produced down the blue hydrogen route. So analyses like these can be really helpful in determining what are the best policy decisions to put in place. Another second example that I have here is from the transport sector. And this is looking in particular about at freight. How can we decarbonise our freight sector, our heavy goods vehicles? And again, there are different options that we might want to try and undertake. Hydrogen is one possibility that's sometimes raised in this instance, but so is producing electrified roads, such that we can use electric vehicles on those roads. And there are different options, and they have different barriers to adoption. That are either technological, economic, or sometimes political, and also different levels of greenhouse gas reductions. And what we've tried to do here is put all those different options onto the same graph so that we can identify which are the best solutions and which ones just simply deliver insufficient benefit, so that we can again help provide critical information for making decisions. Now, the next dimension that I'm going to talk you through is nature. How can we look to solutions based on nature that help us address climate change, either by reducing emissions or by helping to adapt to some of the impacts of climate change? But also, how can we do so in a way that helps support nature itself? There are a number of ways in which we could be deploying those nature-based solutions, but they really do need to be carefully designed. There's been a lot of focus in recent times on planting of trees, and of course trees are nature's great way of soaking up carbon dioxide, but planting the same tree species in areas that are unsuitable can have a very detrimental impact on local biodiversity. And so any nature-based solutions really do need to be carefully designed. But if they are, they could play a really significant role. We've been advocating for the creation in the UK of a new national nature service. This would again help to provide jobs of the future, and those jobs looking to both restore nature, but also to help with these nature-based solutions. And of course, a critical part of our nature is the agriculture, which is so much of a critical part of our natural world. And so very much focusing on how we can overhaul the policies incentives in terms of both agriculture and rural development, but do so in a way that's very much informed by the evidence base. And then finally, food production, which again is a critical part of our agricultural system. How can we make our food production more sustainable? In part, that's about reducing food waste, not just food waste in our homes, on our plates, but food waste all the way from the farm through the food production system to our plates. At each stage, there's significant wastage at the moment that could be significantly reduced. And how can we look to promote healthier diets, but also diets that have less impact on the natural world? Impact in terms of carbon, impact in terms of water use, and impact in terms of land use. There are huge opportunities for looking to develop solutions that have both positive health impact and a positive environmental impact at the same time. This is one example that is linked to work that's being undertaken in Cambridge. This is Polessia, which borders Belarus, Ukraine, Poland, and Russia, and it's one of Europe's largest natural landscapes. It's home to bison, bears, wolves, and lynx, and there's a key effort to look to see how we can restore this landscape. Restore it so that it provides greater flood defences, helping in terms of the future impacts of climate change. Restore it so it provides greater water supply to the communities that are served by it, and also restore it so that it provides more carbon storage. But understanding how we can conduct the right land management practices to have those positive impacts both on climate and on nature, as well as the positive impacts for the communities in the region, requires very careful analysis. And again, to come back to a common theme throughout this presentation, it requires a systems perspective to understand all those interconnections. Now, the final lens that I'm going to discuss is the international lens. And again, there's 4 key points that I've highlighted here on the international dimension that close off the picture of how we might, over the coming months and years, start to look at developing a green recovery from the current pandemic. The first, and this is looking very much from a UK perspective, but it's true for other countries of the world as well, is to look to develop and demonstrate international leadership. There are key events in the coming 12 months that are going to be critical to the international response, both to climate change and to the biodiversity challenge. The greatest of those is now being delayed by 12 months because of the COVID crisis, and that is the next big United Nations climate conference, which will be happening in Glasgow in 2021. And the UK, together with Italy, hold the presidency of that. That is really the major opportunity for the world to come together and to agree to ambitious action to limit future climate change. And there is a huge amount of hope that indeed countries will come together and recognise the scale of the contribution that they all that is needed by all of them, and not just by countries, also critically by cities, by regions, and by businesses of the world, because it's every part of society that needs to contribute to ensure that we are on the journey at the scale and at the pace that is required. The second thing that I have here speaks back to a point that I've made in a number of occasions through the presentation, which is the critical need to look to our education and skills training. If we are to respond to these challenges, we need people with the skills to understand both the scale of the challenges, but more importantly, how to deliver the solutions. And so if we can look to see how we can help coordinate and deliver a global response to the need for education awareness and building capacity on both climate change and biodiversity conservation, then we could play a really important role. In terms of the current coronavirus pandemic, responses, I think, have been very focused on the immediate threat and consequently have been very focused on national efforts. But as we look to the future and to the coming years, then we need to be looking at how we can generate international cooperation. International cooperation, both in terms of our global economic recovery, but also in terms of how we respond to these environmental threats. And then the final point that I have here is looking to see how we can leverage pandemic recovery investments to help implement both the Paris Agreement and, of course, more generally, the Global Sustainable Development Goals. So I hope that's given you a little bit of sense of, well, first of all, the scale of the environmental threats that we're facing in the midst of an immediate health threat, the need to respond to those environmental threats at the same time as responding to that health crisis, and the opportunities for responding to that and developing solutions, but finding ways of developing both the investments, the infrastructure, the policies, and perhaps most critically, the systems thinking that's going to be required to build an inclusive, resilient, and sustainable future, a future that is based on us living in greater harmony with the world that sustains us, a greener future. This image that I show here is one of my favourite photographs. It's the photograph that was taken from the Apollo spacecraft back in, over 50 years ago now. And it's the very first image of the Earth from space. And I particularly like it because I think it shows more than anything the uniqueness and the beauty of the planet on which we live. There is only one Earth, and it is decisions that we make over really the coming years that are going to determine the world that we leave for our children and grandchildren and their children and grandchildren. It's the scientific and the technological advances that we make over the coming decades that will determine that future as well. And so I really hope that, if anything, this lecture has inspired you to help contribute to those scientific and technological developments and to support the need to move to a greener future. Thank you very much.
Apologies. I was saying thank you so much, Emily, for a very inspiring lecture. I think it really is a dramatic call to action, as well as a really comprehensive overview of the scale of the challenge. I've got a number of questions here that have come in both from Twitter and I think from other sources as well. And the first one is really just taking two questions together, really, but is reflecting on some of your final points on regarding the COVID-19 pandemic. And asks, what behavioural changes can we learn from this pandemic that can help with controlling climate change? And also, how will some of those things that have come out of the pandemic, such as social distancing, stand in conflict with building a greener future? And what can we do to overcome that?
So that's a really good question. And I think it's very interesting. I think one of the key lessons of the pandemic is that, painful though it has been in terms of the very great limitations that have been put on all our lives, I think there's perhaps two lessons. One is that we have all responded and undertaken very great behavioural changes forced over the last few months, and I think that shows that rapid change is possible. I think the other aspect is that there are some elements of our change in behaviour which actually probably haven't been such a bad thing, we may wish to look to see whether we can continue into the future. The fact that we've been doing very many more virtual meetings has been quite painful at times, but on the other hand, if we can continue some aspects of that such that we don't immediately hop on a plane for work quite as often as we have done in the past, and we have more virtual meetings, well, that might not be such a bad thing, and it would certainly be better for the climate. So I think the key thing is to identify those aspects that perhaps we wouldn't have adopted so easily, but because we have been forced into them, we've perhaps recognised that actually there are some advantages.
Yeah, I think that's some really, really interesting reflections. And I think on, when it comes to the kind of broader scale of question, there's a lot of interest here in your statements about what we might need to change about how we think about our own economy in order to get to that point. And so, for example, one question is, how do we mobilise a shift in societal values towards these new economic metrics you mentioned that prioritise the environment?
Yes. Well, so first of all, I think a key element there is to Well, the key element is to design those economic metrics, because it's not straightforward to understand how one, how should we design a new measurement of prosperity? How should we incorporate the well-being? I think we all sort of feel that our own well-being ought to be part of measures of prosperity. Many of us feel that actually the well-being of the natural world ought to be part of it, because I think most people understand that things like pollinators do provide a really critical service to us, and finding ways of recognising that service, valuing nature, is probably important. But understanding exactly how we construct that, I think, is the first stage. And then, in a way, this is where political leadership comes in, isn't it? We need people to be providing that global political leadership to help give us the vision of where to be moving as a society. And I think that it's a combination of the two. It's providing the framework, but then also providing the leadership.
Yeah, I think that is really interesting, and I think it's really interesting that in your lecture you outlined, I think, some really quite concrete things, whether it's heat insulation and things like that, which kind of arise from looking at the whole of system approach that you're describing. And so I guess, you've talked about the leadership and the framework that's needed, and then some quite concrete things. And how do we kind of get the system moving quickly enough, do you think, in order to meet this goal by 2050? What should we be doing first to shift these systems?
Yes. So, well, again, so one of the recommendations that this report, by the way, is being launched from Cambridge University on Friday. So if people want to, learn more details about it, then they should look out for the full report on Friday. But one of the recommendations, which I mentioned, was that at least in the UK, and I think that the same would be true of many countries of the world, we need to be looking at how we can provide the infrastructure to help develop coordinated responses. There's no single response. I think that image that I showed you of the scale of change that's required across every sector of society, I think gives an indication there's no magic bullet solution. We can't just say we're going to decarbonise the energy sector, of which we've already done a significant amount, and think that that's ticked box and we can move on and not worry about anything else. We have to look in a really systems-wide perspective, but that means that we need the infrastructure and the government frameworks in order to be able to do that, in order to be able to reach across what are, frankly, traditionally very siloed activities, such that our policies and regulations, investment and support in the transport sector is appropriately connected through to the ways in which we're developing our energy infrastructure, not least because as we move towards more electric vehicles, that can only be delivered if we also have a decarbonised energy sector. So these things really have to work together, and at the same time, we can't have a transport sector that isn't properly connected to the way that we design and build our cities. So it's connected together with the infrastructure and construction sector as well. And that in itself is intimately related to the agricultural sector, because that agricultural sector needs to serve those cities, and etc. So unless you look in a really holistic way and in a joined up way, then you simply can't deliver the change that's required, and you certainly can't deliver the change that's required over such a short timescale. The real challenge here is that in a way, we've left it rather late to respond to climate change. We've known about the threat for at least 30 years. The first Intergovernmental Panel on Climate Change report came out in the early 1990s that was very clear about the scale of the challenge that climate change posed. But now we have left it late. We've got such a short time in which to act. There's really not an opportunity to make mistakes. And that is another reason for ensuring that we really do have a joined up approach. So many of these aspects, because this is so interconnected, also means that if you make a mistake, that mistake can perpetuate through many different aspects. You can have all sorts of negative and unintended consequences of what might otherwise be a good action. and you want to make sure that you avoid those. You can only do that if you look from a systems perspective. But the flip side of that is, because everything is so interconnected, you can have very strong positive benefits across many different sectors. And I mentioned some of those already in terms of benefits. When I was talking about a sustainable food, I was talking very much in terms not just of the climate impacts and positive climate impacts, but the positive health impacts as well. And that's just one of very many examples where action on climate can also have significant other benefits through the system.
Yeah, I think that's really fascinating, and I think when you pick it apart, you can see all these connections, and it becomes obvious that, of course, your transport system needs to chime with whether we're shifting out of offices in city centres or whatever it might be. But the challenge of seeing it in that way is obviously one that we're still working on. But I think that's really an exciting way of looking at it. Another kind of question, which is, I guess, somewhat linked to this, is around the technologies that you've mentioned. Are there particular technologies that you find most promising that you think we should be focusing on developing? And I guess related to that, one particular technology, rather more old-fashioned one perhaps, that some people have asked about is nuclear energy in particular, and whether you see a space for that in this system.
Yeah. So, I mean, in terms of the technology, I know some of I think the most exciting are ones that I've mentioned already. And in terms of the ones that are probably the highest priorities for making a significant impact, if I look at where our greatest emissions currently come from in the energy sector, there are clearly significant advances that can still be made in terms of the efficiency of photovoltaics. It's still significant opportunity, even though there's been great advances in that area already, and battery storage technologies are going to be absolutely critical as well if we are to deliver the electric vehicles of the future. And again, thinking about things in an interconnected way is not just those technologies themselves, it's also thinking through the environmental impacts of those technologies, and so making sure that, again, as we develop those technologies, we're doing so in a very systems thinking perspective. In terms of some of the other key advances that I think are really important to have a greater understanding of from a research and development perspective are perhaps the greenhouse gas removal technologies that I was mentioning. And that really is looking both at engineering solutions, potential ways of removing and then storing carbon dioxide from the atmosphere, but also, just as importantly, looking at nature-based solutions. So looking, for example, not just, as I mentioned, planting the same tree in the same place, which would have a very negative consequence for biodiversity, but looking at how we can restore nature, how we can increase the organic content of soils, for example, to find ways in which we can get nature to help us in reducing our climate emissions, but at the same time helping nature itself to restore.
You've neatly answered my question, which was going to be about biodiversity. But I think it's very clear that does play an important role in sustainability as well. So I realise we're running out of time, but I think we have one or two more questions, if that's okay with you, Emily. And I guess one of them is perhaps about the international sphere of this, which is, what is the role of international agreements and international cooperation to create the zero carbon future, and what should international governments be pushing for in that space?
Yeah, so I think it's both. International agreements on this are clearly essential. This is a global problem, and it requires a global response. So let's be absolutely clear about that. And in this next 12 months, as we move to the run up to COP26, then we really are looking to international governments to make increasingly ambitious commitments in terms of their emissions reductions, in line with what the science is indicating is necessary. But at the same time as those global international agreements, that change is going to be enacted at a local level. It's going to be enacted by cities and regions, and it's going to be enacted by our businesses. And indeed, it's going to be enacted by all of us as individuals. So it's equally important that we see commitments from all sectors of society in terms of ensuring that the entire global society moves in that direction towards net zero emissions as rapidly as possible. And I think that that is equally important. And so we saw in Paris 5 years ago a commitment of global countries to limit climate change warming to 2 degrees Celsius, with an ambition to keep it to 1.5 degrees Celsius, half a degree warmer than we are at present. And the critical thing, I think, now is to translate that through to what that actually means in terms of the way in which our economies operate. So translate it through to a rapid transition to electric vehicles in all countries of the world. Translate it through to preventing deforestation throughout the world, and ensuring that through supply chains that deforestation is not ending up in our living rooms. And looking at seeing how we can support those nature-based solutions in different parts of the world, and at the same time looking to see how we can help those communities that are most impacted by climate change today and will be most impacted by climate change in the future. So I think there's quite a number of different areas that we need to be looking at over the next 12 months to turn those high-level ambitions into on-the-ground action at a local level, at a sector level.
Yeah, I think that's really true and interesting to reflect on, the kind of spectrum of action that needs to take from the kind of grand scale down to the individual. And I suppose for individuals who are here today, who are listening to this lecture, what kind of actions would you most like them to take away as their kind of top thing that they should do or think about, or as well as read your report, of course, after this?
Yes, so I often get asked that question, and I think I think every individual can contribute greatest in different ways. So for many people who have an interest in science and technology, as I've described, advances in science and technology are going to play an absolutely critical role over the coming decades. And that's actually very exciting. This is an incredibly exciting time to be involved in creating the ideas and the innovations that will help shape a greener, more sustainable, more resilient future. And as I think I've indicated, there are so many exciting opportunities for getting involved in those major scientific advances in so many different dimensions, involving engineers and physicists and biologists and many other disciplines as well. So that's undoubtedly one area to actually get involved in developing those innovations. Of course, there are ways in which we could all individually change our behaviours in order to help support the cause, or indeed to individually look to see how we can inspire others to do the same. So we scale that up, and then we're sitting on the day where we still don't know the results of the US election, which I think has to remind us all that actually using our democratic voices is also incredibly important.
That's wonderful. Thank you so much for joining us today, Emily, and for some really thoughtful discussions following the lecture. I will now hand back to Professor Thompson.
So thank you again, Emily, also from my side for this very inspiring lecture. There are many aspects, including the one of the democratic voice that you uttered in the end, that are paralleled at our institution. We also believe that science is at the foundation fighting against the climate change. There are many subject areas, you mentioned many of those, that if they work together in a coherent way, if science takes this issue as a global undertaking, a global endeavor, then we'll have a chance, or said the other way, if we don't do it together, then we won't have a chance. So managing the climate change is a mission that we must not fail in favor or in regard of our children and all those people that will live on Earth after us. And it is really the challenge. And you said, which I like very much also, is we don't have 2 or 3 choices to try out how it's going to work, but we have to do it the right way right now. So let me take the opportunity to thank those involved in organizing the event. That's foremost the British Embassy. That is also the British Council. That is the team at TU Berlin at my university who has been organizing things. And so your effort is highly appreciated. And this unusual form, this completely digital form, I think it worked well. Everybody saved traveling. Everybody saved some CO2 emissions in getting here. Still, we had an excellent lecture. Normally, the other lectures, I would give you, Emily, a certificate for having participated having spoken at the Queen's lecture. We'll put it in snail mail, and I'll be curious how many days it takes until you get it. But I think we'll send it off tomorrow, and we'll find out. So that's all from my part. I wonder whether maybe the embassy wants to contribute one more statement, Mr. Bullock.
Yes, thank you very much. I'd just like to add our thanks, Emily, for a really inspiring lecture. As an embassy, we have a lot on our plate, of course, but many of us are gearing up and looking ahead next year to COP26, which will form a large part, not just of what the embassy in Berlin is doing, but what the entire FCDO global network will be involved in. And I think the point you made that this is not just about governments at the state level, it's also about city mayors, it's about local organizations, and that's a message that we take with us as well. So thank you very much for sharing your ideas with us this evening.
So thank you very much from my part to everybody involved, in particular to you, Emily, and have a good evening, everybody. Bye-bye.